talk a little bit about constant proportionality. These are just some notes that I use as a handout when I taught it from years past. I'll go through a little bit of this with you and then look at a couple of example problems together. So constant proportionality, it might be represented by a lot of different things. You might see this the letter K, that you see that shows up again down here in this equation. It might be called rate of change, change in Y over change in X. Once you get later on down the road, particularly 8th grade, they call it slope. Might be known as rise over run. So you might hear it called several different things. I don't have it up here either, but it's also known as unit rate. And so constant proportionality is something that you'll hear from time to time. So it's important to make sure you remember that term. Direct variation is something that, in terms of a relationship, whereas x and y, whereas a relationship is where x increases, y increases or decreases at a constant rate. And so the constant rate would be the constant of proportionality. So the direct variation equation is actually down here. We'll talk about that in a second. Over here, I want to show these graphs before we get into the direct variation equation. It says the graph of a direct variation equation is a straight line that passes through the origin. Remember, the origin is point 0, 0 on a coordinate plane. So here you see this line is not passing through the origin, so therefore I put a little X saying no, it is not a graph of direct variation. Same thing over here. This is a straight line, but it's not going through the origin, so therefore I put a little X saying that is not going to be a direct variation graph. This one is a direct variation graph because it's a straight line that goes through the origin. So therefore, when you see some problems later on, remember this little piece of information to kind of help you solve some of those problems. The direct variation equation is going to be y equals kx. Remember, k is going to be represented by the constant proportionality. So the constant proportionality equation will be k equals y over x. You really just take the same equation right here, and if you divide both sides by x to get k isolated, in other words, get k by itself, you would have y over x. That's where this equation comes from here. So when you're trying to find the constant proportionality with some of these problems you're going to look at, this will be the equation we're using here, which will be y divided by x. So I'm going to move this up a little bit. You see I've got some examples right here. So with these three tables, you see I've got the x column and the y column. So here I'm just taking, it really doesn't matter which two groupings, or I guess groupings being these two numbers across each other, so which two numbers you're choosing in terms of which grouping you want to use. Here I could do 20 divided by 2. Remember, I'm doing y divided by x because that's our constant proportionality equation. So I can do 20 divided by 2 and get 10. Somebody else may have done 40 divided by 4. Somebody can do 60 divided by 6, 80 divided by 8. All that will give you 10 when you're trying to find the constant proportionality. Down here for the second one, once again, you're doing y divided by x. So choose two numbers that are across from each other. So here I just did 12 divided by 2 and got 6. You could have done 24 divided by 4, 36 divided by 6, or 48 divided by 8. Either way, you get 6. And then finally down here, you see we've got this table. So once again, y divided by x, I just did 40 divided by 1 to get 40. But any of these other pairings would also give you 40 if you do y divided by x. Make sure you do y divided by x when it comes to constant proportionality. A big thing that I've seen different worksheets and problems try to trick you on is if it's multiple choice, they may say the answer is x divided by y. It's like over here, instead of saying 40 is the answer, they say the answer is 1/40. So just be careful on a situation like that. Always do y divided by x when it comes to constant proportionality. So we looked at a couple tables over here. Let's check out these graphs. So you can see I've got these couple of graphs over here talking about constant proportionality. And it says the graph below represents the speed of a car. So what is the constant of proportionality? So that's what we're finding here. So remember, when you see a coordinate plane, this is quadrant 1 here. X is going to be the horizontal line, so x is represented by miles. Y is going to be the vertical line. That's the speed in this particular case. So choose somewhere, and you notice, by the way, it's a straight line going to the origin. So you know it's going to be a direct variation graph. So choose one of these dots here and use the number pairing that's on these dots. I'm just going to choose the lowest numbers here to work with, but you could use the 60 and the 120 and the 90 and the 180. All that stuff will work too. So once again, we're going to be doing y divided by x. And then we'll come over here. Remember, my y value is going to be these numbers here. So I'm going to use this dot. I'm going to do 60 divided by 30. And when you do 60 divided by 30, this is something I've taught some of my students in the past. It's they can slice off basically a 0 on the top and bottom. So however many zeros you take off the top, in other words, your numerator, you can do the same thing on the denominator. So basically, this is the same thing as 6 divided by 3. So I'm showing you that because a lot of times I'll get people that'll tell me this answer is 20. And so if I take the zeros off, I say, what's 6 divided by 3? They say 2. I was like, yeah, it's not 20. So therefore, same thing here. 60 divided by 30 is going to give you 2 for your answers. So that's my constant of proportionality in this particular problem here. Now, when I say take the 0 off the top and bottom, the same thing as dividing by 10 on top and bottom, and that's how you get down to just 6 over 3. Up here, like I said, you could have done 120 divided by 60 or 180 divided by 90 and so forth. Either way, you still get 2 for your constant of proportionality. The second graph over here, it says we're talking about representing the total kilometers Jack walked in hours. So what is the constant? What is the constant of proportionality? So once again, you can choose one of these dots to work with. Remember, we're doing y divided by x, not x divided by y. So here I'm going to go ahead and take this first one, so 40 divided by 1. And you could have done 80 divided by 2, 120 divided by 3, 160 divided by 4, or 200 divided by 5. Either way, you get this answer of 40. And what you're seeing there basically, just kind of go back in and reference this. So this is what we just looked at a minute ago. This is actually a table format of this graph here. So this graph here, you saw these same numbers. So you saw the y was 40 and the x was 1. So the y was 80 and the x was 2. You saw the y was 120, the x was 3. The y was 160, the x was 4. I didn't put in the 200 and the 5 over here, but same thing. So this is actually the same problem right here. Just one's a graph and one's a table. Let's look at a table that might be horizontal and solve some of these problems. So notice we have this table right here. And it tells you to do a couple things in this problem here, but I'm just going to focus on this. I want us to find the constant of proportionality again. So once again, we'll do k equals y divided by x. And when you see this horizontal table, x will be your top value and y will be your bottom value. Same thing with this one down here. X will be the top line, y will be the bottom line. So over here, just take grouping again. So two numbers that are right next to each other. So over here, I'm going to use the 4 and the 1s. Remember, this is my y, this is my x, so it's 4 divided by 1. You could also say 8 divided by 2, or 12 divided by 3, 16 divided by 4. They all give you your answer of 4 there for your constant of proportionality. So I'm going to move this up a little bit. And I've got an example of a table and an example of a graph here. Now, I know this one's telling you to do a couple things here. I still want you to just go back in and find constant of proportionality. Don't worry about doing anything else it tells you. So over here, take a couple minutes. I want you to pause the video and you try to solve this table for number 2. Remember, finding the constant of proportionality. And then try to find the constant of proportionality down here for this graph in number 3. So pause this video, try these two, and we'll see how you do. Okay, so for this one up here, once again, you're doing y divided by x. So I don't care which grouping you took here, I'm just going to do 4 divided by 2. You all may have done 8 divided by 4, 12 divided by 6, 16 divided by 8. Either way, you get an answer of 2 for your constant of proportionality. And down here on this graph, same thing we're doing again, find the constant of proportionality. So it's still going to be k equals y divided by x. So I'm going to choose this first dot here. I'm going to put 5 for my y, 1 for my x at this point. And then I get 5 when I divide 5 by 1. Here you could have done 10 divided by 2, 15 divided by 3, 20 divided by 4, or 25 divided by 5. Regardless, you'll get 5. So this is just an example of here, some notes of constant of proportionality, but also some tables that you may see constant proportionality on, and some graphs as well. All right, that concludes this constant proportionality lesson.